Good morning students. Today we will see coordinate geometry fundamentals and basics. So in coordinate geometry concepts are very important. All the problems they depend on concepts only. So listen carefully. So coordinate geometry 2D, two-dimensional geometry. What is two-dimensional geometry? There will be two axes, one horizontal line and a vertical line. These are two mutually perpendicular lines. One is horizontal and another is vertical with their intersection capital O. The plane containing these things is called coordinate plane. Of course, two-dimensional. This horizontal line is called x-axis, vertical line is called y-axis. So on this side there will be all positive values 1, 2, 3, 4, etc. This is called positive x-axis. And on the left side of this we will take negative values -1, -2, etc. It is called negative x-axis x dash. So this is called y-axis, vertical line. This is positive y-axis and this is negative y-axis. Here we will take positive y values, negative y values. This horizontal line is called x-axis, vertical line is called y-axis. It is a two-dimensional geometry, therefore there will be only two axes. Their intersection is denoted by capital O, which is called origin. So these two axes, they divide the plane into four equal parts. This one is called first quadrant. This is the second quadrant, third quadrant and fourth quadrant. These are the four quadrants. The two coordinate axes divide the coordinate plane into four equal parts. Each part is called a quadrant. This is first quadrant, second quadrant, third quadrant and fourth quadrant. Since it is coordinate geometry, what is coordinate geometry? The geometry which depends on this coordinate plane. Entire this system is called coordinate system. In this coordinate plane there will be infinite points. Every point in this plane is denoted by an ordered pair x comma y. Any point, there will be many points. For example, a point is here, capital P. Every point in the plane is uniquely represented, uniquely denoted by an ordered pair. If I denote this by ordered pair x comma y, then it will be representing this point. Here x is called first coordinate or x coordinate, y is called y coordinate or second coordinate. If the point is in first quadrant, then both coordinates will be positive. X is greater than 0, y is also greater than 0. If the point lies in the second quadrant, x is negative, y is positive, x less than 0 and y is greater than 0. If it lies in third quadrant, x is negative, y is also negative, x less than 0, y is also less than 0 if the point lies in third quadrant. If the point lies in fourth quadrant, then x will be positive, y will be negative. X is greater than 0, y is less than 0. So this is the coordinate plane. These are the coordinate axes. This common point of two perpendicular lines is origin. So we will be taking origin as 0, comma 0. Coordinates of origin are 0, comma 0. Any point in the plane is represented by x, comma y. If a point is on x-axis, then its y coordinate will be 0. Therefore, any point on x-axis, on x-axis is of the form x, comma 0. So if y coordinate of a point is 0, then we say that the point lies on x-axis. And similarly, any point on y-axis is of the form 0, comma y. So if a point is on y-axis, then its x coordinate will be 0. And one more important thing, if a point is given, these are the coordinates. The two coordinates will be stating the position of the point P with respect to coordinate axis. Okay, if I take a point capital P, x, comma y, then x coordinate says that this point is at a distance of x units on x-axis from origin. So this will be the x coordinate of this point, and y coordinate states that this point is at a distance of y units away from origin. This is y-axis. Y coordinate says that this point is at a distance of y units on y-axis from origin. So this is the meaning of first coordinate and second coordinate. So this length is x, therefore this is also x. This is y, no, this is also y. We can state an important, very important basic point here. Number 1. If a point is given x, comma y, then the distance of the point to x-axis. Distance of the point to x-axis is what? Y. That means equal to y coordinate. So therefore, distance of a point x, comma y to x-axis is magnitude modulus of y coordinate, and distance to y-axis is the distance of the point x, comma y to y-axis is what? Mod x. Right. Therefore, if a point is given, the distance of the point to x-axis is magnitude of y coordinate. Distance of this point to y-axis is magnitude of x coordinates. Yes, these are the coordinate axes, x-axis and y-axis. X-axis, y-axis, this is origin. In this coordinate plane, there will be three types of lines. The lines which are parallel to x-axis are called horizontal lines. Horizontal lines. Horizontal lines means x-axis itself and any line parallel to x-axis. All these are horizontal lines. Next type of lines, vertical lines. Vertical lines. What are vertical lines? Y-axis itself and any line parallel to y-axis. All these are vertical lines. And number 3, Inclined lines or oblique lines. Inclined lines or oblique lines. What are inclined lines? The lines which are neither horizontal nor vertical, that is neither parallel to x-axis nor y-axis. All those lines are called inclined lines. They will be having some inclination. All these are inclined lines. Okay, if you take horizontal lines, what are horizontal lines? The x-axis itself and any line parallel to x-axis. They are horizontal lines. One of their properties, if you take any horizontal line, for example, if you take x-axis, points on x-axis will be 1, 0, 2, 0, 3, 0, minus 1, 0, minus 2, 0, etc. If you take another horizontal line here, for example, this is also a horizontal line. If you take the points on this, if it is at a distance of 2 on y-axis, then this will be 1, 2, 2, 2, 3, 2, etc. What is our observation? If you take any horizontal line, then its y coordinates will be equal. That is, if you take a horizontal line, y coordinates of all the points on a horizontal line are equal. Similarly, if you take a vertical line, they are parallel to y-axis, therefore their x coordinates are equal. If you take an inclined line, both will be different. If you take the points on an inclined line, all the points will have different x coordinates, different y coordinates. If I take a line passing through 2 points, x1, y1 and x2, y2. Say a line is passing through these two. If this line is a horizontal line, then its y coordinates are equal. y1 equal to y2. If it is a vertical line, then x coordinates are equal. x1 is equal to x2. Here y1 equal to, for a horizontal line, y1 and y2 they are equal. x1, x2 definitely they are different. Here x1 equal to x2 and y coordinates are different. If you take an inclined line, for inclined line both will be different. x1 is not equal to x2 and y1 is not equals to y2. So these are the three lines, especially these are very important. What we are studying, they are all basics of any concept, any chapter, any subject are at most important. All further things, further applications, further formulas, further properties, they all depend on basics only. Next, we will see distance between 2 points. Distance between 2 points. Distance between 2 points. See, if 2 points are given in the coordinate plane, then its distance can be calculated. So the distance between the points x1, y1 and x2, y2. Yes, the distance between these 2 points is, distance is root over x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula to find distance between 2 points. In the plane, these are the 2 points, A and B. To calculate distance between these 2 points, we use this formula. Here order of the points is not important. Among A and B, you can choose this one as x1 y1 or this one as x1 y1. It makes no difference because distance from A to B is same as distance from B to A. So therefore this is distance between 2 points. Now and then we will find the distance between origin and a point. That is, if one point is origin, then the distance will be very simple using the same above formula. This is what? Root over x2 minus x1 whole square means x square. y2 minus y1 whole square is what? Y square. This is distance between two different points. If one point is 0, 0, then distance between 0, 0 and x, y can be root over x square plus y square. Next, point of division. Points of division. That is, it is called section formulae. Section formulae. If 2 points are given x1, y1, x2, y2. These are the 2 points x1, y1, x2, y2. This is a line segment. This is a line segment. What is this? It is a line. If you take this portion, this will be a line segment. So, if a point is dividing this line segment in the ratio m is to n internally, then how to find its coordinates? The point which divides the given line segment in the ratio m is to n internally. Internally means the point will be lying between the two given points. To calculate this point of division or this section, it is mx2 plus nx1 divided by m plus n. Similarly, y coordinate my2 ny1 divided by m plus n. This is internal point of division. When the point is dividing internally, this is the formula. There can be one more point which divides the same line segment in the same ratio externally. So for external point, how to find external point? External point is given by mx2 minus nx1 divided by m minus n, and y coordinate my2 minus ny1 divided by m minus n. So this is a line segment. Say this point is capital A, this is capital B. AB is a line segment, only this portion. The point capital P is dividing this line segment in the ratio m is to n internally. Then the coordinates of point P are mx2 plus nx1 by m plus n, my2 plus ny1 divided by m plus n. The point Q is dividing same line segment in the same ratio m is to n but externally. That is minus indicates external division. So the point Q is this one. So these are the 2 points of division which divide AB in the ratio m is to n internally and externally. Right. Then we will have one more. If AB are ends of a line segment, then midpoint can be found. What is the midpoint of AB? Midpoint means that will be dividing AB internally in equal ratio 1 is to 1. If you put m equal to n in this internal point of division, you will get midpoint. So what is the midpoint? It is x1 plus x2 by 2 and y1 plus y2 by 2. This is the midpoint. So these are the points of division. So if a line segment is given, this is the procedure to find internal point, external point and midpoint. Okay, now we will see one application, that is, this is a line segment. One extremity is given x1, y1 and midpoint is given x comma y. Generally these two will be given, then we use to find midpoint. Instead of that, one end is given and midpoint is given. Then how to write the other extremity? Very simple. Other extremity will be 2x minus x1 comma 2y minus y1. This is other extremity, very useful in problems. Next, points of trisection. What are the points of trisection? If a line segment is given, this is a line segment. Points of trisection. If a line segment is given, the points which divide this given line segment into three equal parts. Three equal parts. The points which divide a given line segment into three equal parts are called points of trisection of the line segment. Since these three are equal portions, these are 2 points of trisection. From the figure it is very clear. First point will be dividing in the ratio 1:2. Second point is dividing in the ratio 2:1. That's all. So points of trisection, the points which divide a given line segment into three equal parts are called points of trisection. So there will be 2 points of trisection. To make this line segment into three equal portions, we need to plot 2 points between them so that we will obtain 3 portions. Okay, the first point of trisection is 1:2. Second point of trisection is 2:1. If you are asked to find the points of trisection, then you should find both. If first point, what is first point of trisection? That means this is the first point of trisection, second point of trisection. So here we have divided a line segment into three equal points. This concept can be extended to some other things, some other concepts. Say here AB is a line segment. Now we have to divide this into 4 equal parts. 4 equal parts means we are supposed to cut in 3 points. 1, 2, 3 and 4. Say these are the 4 equal parts. So we have divided AB line segment into 4 equal parts. So to divide the line segment AB into 4 equal points, 3 points are required. So the first point will be dividing in the ratio 1:3. Second point will be dividing in the ratio 2:2. 2:2 nothing but 1:1, that is midpoint. And the third point is dividing in the ratio 3:1. This can be extended to any number of times. So you can find the points which divide the line segment into 5 equal parts, 6 equal parts, etc. Next we have one more important one, harmonic conjugates. Harmonic conjugates. Harmonic conjugates. What are harmonic conjugates? Very simple. If a line segment is given, then there will be 2 points which divide the given line segment in the same ratio internally and externally. Those points are called harmonic conjugates to each other. See now, for example, this AB is a line segment. AB is a line segment. Line segment means a finite portion of a line. Say capital P is a point which is dividing AB in the ratio m is to n. Then definitely there will be another point which divides AB in the same ratio externally. Therefore, the 2 points P and Q, they are dividing same line segment in the same ratio. One is internally and another is externally. Such points are called harmonic conjugates. P and Q are harmonic conjugates. Harmonic conjugates with reference to or with respect to line segment AB or simply AB points. Why this name has given harmonic conjugate? Because if P and Q are dividing AB in the same ratio internally and externally, then these lengths, these portions AP comma AB comma AQ, they will be forming a harmonic progression. These 3 lengths are in harmonic progression. That's why they have given this name harmonic conjugates. Okay, once again, what are harmonic conjugates? The points which divide a given line segment in the same ratio internally and externally are called harmonic conjugates with respect to the line segment AB. If PQ are harmonic conjugates, then the lengths AP, AB, AQ, they will be in harmonic progression. If P comma Q are harmonic conjugates of AB, then AB also, A comma B points also harmonic conjugates. Harmonic conjugates with respect to PQ line segment. This is important. If P and Q are harmonic conjugates of line segment AB, then AB are harmonic conjugates of line segment PQ. Okay, if P and Q are dividing AB in the ratio m is to n. Both ratios are same, equal. This is internal, this is external. Minus stands for external division. Yes, the points P and Q which are harmonic conjugates, they are dividing AB in the ratio m is to n internally and externally. Here we said if PQ are harmonic conjugates with respect to AB, then AB also harmonic conjugates with respect to PQ, and this A comma B, they divide this line segment PQ in the ratio m minus n is to m plus n. This is important. M minus n is to m plus n. In this ratio, one will be dividing internally and other will be dividing externally. So this is about harmonic conjugate. Right. Next we will see one more property. If a triangle is given, this is a triangle. Say ABC is the triangle. So DEF be their midpoints. These are midpoints. Generally vertices will be given and we can find the midpoints easily. When midpoints are given, so x1, y1, x2, y2 and x3, y3. If midpoints of the sides of a triangle are given, how to write the vertices? Very simple. To write the vertex A, what is A? Here A vertex is opposite to this. Therefore, we will use the property sum of these two minus opposite one. That is E plus F minus D. Using this property, we write the vertex A. This property is used for both x coordinates and y coordinates. Now I am writing the point A. We will take x coordinates, sum of E plus F. That means very simple, sum of these two minus this. So it will be x2 plus x3 minus x1. And same property for y coordinates, y2 plus y3 minus y1. Similarly, if I write vertex B, B is opposite to this, therefore sum of these two minus this, that is F plus D minus E. Using this property, we will write the coordinates, sum of these two, x3 plus x1 minus x2 and y3 plus y1 minus y2. This is vertex B. And obviously same, third vertex C. C is opposite to F. Therefore, sum of these two minus this. The property is D plus E minus F. D plus E. What is D plus E? x1 plus x2 minus x3 and y1 plus y2 minus y3. This is the way of finding vertices when midpoints are given. So there is another concept. If a parallelogram is given, this is a parallelogram. It can be any parallelogram. What is a parallelogram? Parallelogram is a quadrilateral in which opposite sides are parallel. Rectangle is also a parallelogram, square is also a parallelogram, rhombus is also a parallelogram. Right, say this is ABCD, it is a parallelogram. So if three vertices, three consecutive vertices are given, x1, y1, x2, y2 and x3, y3. These are the three vertices taken in a row. Then how to write vertex D? So D vertex. Here D vertex is opposite to this. Same property you can use here also. Sum of these two, that is A plus C minus B. So what is this? Sum of these two. We will use this property to write x coordinates as well as y coordinates. If I take x coordinates, x1 plus x3 minus x2. Same property for y coordinates, y1 plus y3 minus y2. Yes. So this is fourth vertex D. When three vertices are given, in this way we will write the fourth vertex. This is applicable for any parallelogram. Parallelogram means all the four basic parallelograms are four parallelograms: square, rectangle, rhombus and parallelogram. Next we will have one more concept. Please listen. If a line segment is given joining x1 comma y1 and x2 comma y2, this is a line segment. If this line segment is divided by x-axis and y-axis, then they divide in what ratio we will see. The ratio in which x-axis divides this line segment. The ratio in which x-axis divides this line segment is, if it is a line segment, this is a line segment joining x1 y1 and x2 y2. This line segment is divided by x-axis in the ratio. To calculate this ratio, formula is minus of y1 is to y2. Minus of y1 is to y2. The ratio in which the same line segment is divided by y-axis. What is that ratio? That ratio is minus of x1 is to x2. This is the ratio. These are all basics and most important things. They look very simple, they look very easy, but they are at most important. So, if a line segment is given, that line segment is divided by x-axis in the ratio minus of y1 is to y2 divided by y-axis in the ratio minus of x1 is to x2. Next, if a line segment joining 2 points capital A x1 y1 and capital B x2 y2, this is a line segment. Line segment means a finite portion of a line. If a point capital P is collinear with this, if a point capital P lying on AB, and that means it is collinear with AB, it can be lies anywhere, outside or inside, then the ratio in which the line segment AB is divided by capital P point is. So when P lies on AB line, they are collinear. P will be dividing in some ratio, no? Therefore, that ratio is x1 minus x is to x minus x2. This is the ratio. Ratio can be calculated using x coordinates or y coordinates. You can also use y coordinates. This is the ratio. The ratio in which line segment joining x1 y1 x2 y2 is divided by x comma y is this. This ratio can be found using x coordinates or y coordinates. Next we will see area of a triangle. Area of a triangle. Area of a triangle. If three vertices are given, three vertices capital A x1 y1, capital B x2 y2 and capital C x3 y3. If three vertices are given, then area of triangle formed by these three, area of triangle formed by ABC points, its area is half mod of x1 y1 1, x2 y2 1, x3 y3 1. So this will give us area of the triangle. It is applicable for any triangle whose vertices are known. So half into this 3 by 3 matrix determinant. So on simplifying, this can be written as 1 by 2 into, simply, that is I am transforming this 3 by 3 determinant into 2 by 2 matrix determinant using row transformations. So x1 minus x2, y1 minus y2, and x1 minus x3, y1 minus y3. What is this? It is a 2 by 2 matrix determinant. In problems this will be good, because this is simplification is just AD minus BC. x1 minus x2, y1 minus y2, x1 minus x3, y1 minus y3. I obtained this by row transformations. The second row can be x2 minus x3, y2 minus y3, no problem. So this is area. Next we have a word collinear. What are collinear points? 3 or more points. Whenever you talk about collinear, you should take minimum 3 points. Collinearity arises when the points are 3 or more. For 2 points, collinearity doesn't have any meaning. So what are collinear points? The points which lie on same line. The points 3 or more points lying on a same line are collinear. If 3 points are collinear, then what are the conditions? ABC are collinear. ABC are collinear implies if they are collinear, they will be lying on same line. Therefore, area of triangle will be 0. Area of triangle formed by the points is 0. If area equal to 0, then they are collinear. There is another methods. If 3 points are collinear, then they satisfy this condition. Sum of any two sides equal to sum of any two distances equal to third one. That is AB plus BC equal to CA, then they are collinear. Sum of any two sides, it can be BC plus CA. That should be equal to AB or BA, or CA plus AB. This can be BC or CB. So 3 points are collinear if area of triangle is 0, or AB plus BC equal to CA, or BC plus CA equal to AB, or CA plus AB equal to BC. What are these three? Very simple. Sum of any two distances equal to third distance, then also they are collinear. Collinearity can be shown with slope property also. If ABC are collinear, then slope of AB is equal to slope of AC, or BC slope of AC. If 3 points are collinear, then slope of AB is equal to slope of BC slope of AC. So using these three, you can discuss this property, collinear points. Now area of a quadrilateral. Area of a quadrilateral. What is area of a quadrilateral? Quadrilateral means it can be any one: square, rectangle, parallelogram, rhombus, or any quadrilateral. A quadrilateral will have 4 vertices: x1, y1, x2, y2, x3, y3, and x4, y4, and x4, y4. These are the 4 vertices of a quadrilateral. Then its area can be taken as, its area can be calculated using this: half mod x1 minus x3, y1 minus y3, x2 minus x4, y2 minus y4. Yes, this is area of the quadrilateral. It is applicable for all quadrilaterals whose vertices, 4 vertices are given. So coming to this, just now we have seen area of a triangle. Say this is a triangle ABC. This is triangle ABC. Its area can be calculated. Say here DEF are the midpoints of sides of the triangle. Then these three midpoints, the three midpoints of the three sides, they will be dividing the triangle ABC into 4 triangles of equal area. So the midpoints, they are dividing the given triangle into 4 triangles of equal area. That means here area of triangle DEF is equal to area of triangle AEF equal to area of triangle BDF also equal to area of triangle CDF. These 4, 1, 2, 3 and 4, they are all of equal area, and all these 4 are 1/4 of area of triangle ABC. This is also an important concept. Midpoints will be dividing the triangle into 4 triangles of equal area. Yes. Next, 3 points. If 3 points are given A comma B comma C, they form a triangle. Three points A, B, C, they form a triangle. They form a triangle. If sum of any two sides AB plus BC should be more than the third side. 3 points will form a triangle if sum of any two sides is more than third side. That is AB plus BC should be greater than CA. So like any two sides, BC plus CA should be greater than AB, and CA plus AB should be greater than BC. If AB plus BC is equal to AC, then they are collinear. If sum of any two sides is greater than the third side, then only the 3 points form a triangle. Now we will see the nature of the triangles. Nature of triangles. Nature of triangles using distance properties. Nature of the triangles using distance properties. If 3 points ABC are given, then number 1, it is called an equilateral triangle. Equilateral triangle if all sides are equal, all the 3 sides are equal. All the 3 sides are equal. That means AB equal to BC equal to CA. Secondly, it can be an isosceles triangle. Secondly, it can be an isosceles triangle. If it is an isosceles triangle, then any two sides are equal. Any two sides are equal. If any two sides are equal, then it is called an isosceles triangle. Next, number 3, right angle triangle. We are discussing through distance properties. Right angle triangle. What is a right angle triangle? If one angle is 90 degrees, then the triangle is called a right angle triangle. What is its property? Very simple. Pythagoras theorem can be verified. If AB square plus BC square is equal to AC square or CA square. This is known as Pythagoras theorem, no? If a sum of squares of any two sides equal to square of the third side. If 3 points ABC satisfy this condition, then it is a right angle triangle. Sum of squares of any two sides equal to square of third. Next we will have one more. Acute angle triangle. Acute angle triangle. What is an acute angle triangle? If sum of the squares of any two sides is greater than square of third side, then it is called an acute angle triangle. Next, obtuse angle triangle. Obtuse angle triangle. A triangle is obtuse angle triangle if sum of squares of any two sides, not only AB, BC, any two, BC square is less than square of third side, then it is called an obtuse angled triangle. Yes. Next we will see the nature of quadrilaterals. Nature of quadrilaterals. Using distance properties. So basically we consider 4 quadrilaterals. They are square, rectangle, parallelogram and rhombus. So we will see the nature of quadrilaterals through distance properties. Number 1. If a quadrilateral is a square, then condition should be 2 conditions. All sides are equal. All sides are equal and diagonals also equal. If all sides are equal and diagonals are equal, then it is a square. So square will be having 4 sides equal and also diagonals also equal in length. These also equal. They are of same length. It is a square. Next, second one, rectangle. Rectangle. So properties of rectangle through distance properties. Only opposite sides are equal. Opposite sides are equal. Only opposite sides are equal and diagonals also equal. Diagonals are equal. So only opposite sides are equal means these two. This and this are equal, this and this are equal. All sides are not equal. And you can see the diagonals from the figure. They are also equal. It is a rectangle. So we are discussing this through only distance properties. Next, number 3. Rhombus. Properties of rhombus. Number 1. All sides are equal. All sides are equal and diagonals are not equal. diagonals are not equal. See, this is a rhombus. It will be like this. All sides are equal. See, all four sides are equal, but diagonals are not equal. So next, number 4, a parallelogram. Parallelogram. What is a parallelogram? This figure is a parallelogram. Here also all sides are not equal, only opposite sides are equal. Opposite sides are equal and diagonals also not equal. Diagonals are not equal. See, opposite side, this and this are equal, another pair also equal, diagonals are. You can observe from the figure, diagonals are not equal. So these are the 4 basic quadrilaterals. Differentiation of these 4 using distance properties. If all sides are equal, then it can be either a square or rhombus. First, if 4 points are given, what we do? We find all sides A, B, B, C, C, D, D, A. If all are equal, then it may be a square or rhombus. Then to differentiate that, we find the lengths of the diagonals. If the diagonals are equal, then it is a square. If diagonals are not equal, then it is a rhombus. Okay, in the beginning, when you are finding sides, 4 sides, if all the sides are not equal, only opposite are equal, then it may be a rectangle or parallelogram. Then again finding diagonals. If diagonals are equal, then it is a rectangle. If diagonals are not equal, then it is a parallelogram. So all these 4 together, they are called parallelograms. They are all parallelograms only. Different parallelograms. So some properties of any all parallelograms, any parallelogram. In a parallelogram, always opposite sides will be parallel to each other. In any figure, this and this are parallel, these are parallel. Opposite sides are parallel in all the 4. In all the 4 diagonals bisect each other. What is diagonals bisect each other's meaning? Diagonals bisect each other means midpoint of diagonals is same. Midpoint of first diagonal, second diagonal is same. Similarly, in all the 4 diagonals bisect each other. In square and rhombus, diagonals bisect each other perpendicularly. Okay, that we will see, that we will discuss later. So these are the basic distance properties of 4 basic quadrilaterals. Yes.